6.3, number 11. How many bit strings of length 10 contain exactly 4 zeros? Let's start off with, showing what a bit string looks like. A bit string is of length 10 is 10 zeros, 10 ones, or 5 zeros, 5 ones, 3 zeros, 7 ones. Just any combination of zeros and ones, right? So maybe here's one bit string of length. It's really length 7, right? But that's an example of a bit string, right? And I could make this one 0, and I could make this one 1, and these can either be 0 or 1, right? And so they're asking us to calculate how many have exactly 4 ones. Well, the answer to that is conveniently C of 10, 4, 10, 4, right? And so this is going to be 10 factorial over 10 minus 4 factorial times 4 factorial. And so the best way to explain this is that, well, when I take order doesn't matter in these bit strings. So whether or not I have 4 ones, here are my things, right? So order doesn't matter, so I'm going to use combinations, right? So whether I have 4 ones here or if I have 4 ones over here, right? It doesn't matter. It's just a bit string with exactly 4 ones. So you're not going to permutate this because a permutation order does matter. Boy, do I want to make sure that I got that one right. Because if I said that one backwards, so I'm checking in the book right now. Permutation, does order matter? Yes, in a permutation order does matter, and in a combination order does not matter. And it gets very confusing whether or not you use combination or permutation. But yeah, so let's solve the problem, then we'll talk more about that, right? So this is 6 factorial, if you haven't already solved it. So this is 10, I'm going to do this kind of the faster way, times 8 times 7, right? So we cancel out the 6 factorial, and we canceled out, the 6 and the 5 and the 4 and the 3 and the 2, right? And so we're just left with 10 times 9 times 8 times 7 all over 4 times 3 times 2. And I wish we could, cancel out some stuff here, right? We cancel out the 8 and the 4 and the 2, right? We can do this 3, right? And so really we can just do 10 times 21, which is 210, and that's your answer. And so the best way to explain these problems really is, I have a very hard time explaining them myself, like the concept behind it, right? Because some people go, well, that's great, but how do I exactly go about doing these problems? Well, let's solve it, and let's see if I can answer that more later. How many bit strings of length 10 contain at most 4 ones? So we're looking at the bit strings that contain 0 ones, 1 1, 2 ones, and 3 ones, right? And so we want to take 10, or C of 10 0, C of 10 1, C of 10 2, and C of 10 3. Taking C of 10 3 is going to give us 10 choices, 10 options taken 3 at a time. That's not a very good way to put it, but what are you going to do? And so we're going to add these up. Plus. We're going to add all this one and this one and this one, all 4 of these. And so C of 10 0 is 10 factorial over 10 over 0 factorial 10 factorial. And C of 10 1 is 10 factorial over 1 factorial 9 factorial. And the way I'm getting these answers, by the way, let me do it on the next one. C of 10 2, let me show you how this method works, right? If you haven't seen it, it's you take this 2 right here, right, and you're going to subtract it from 10. 10 minus 2 and take that factorial, right? And then you're going to multiply this here by 2, this number here, right? You're just going to multiply by that number there, factorial, right? And so let's get ourselves a clean slate. Don't save, right? And so we were here, 10 factorial over, let's rewrite what we deleted, 0 factorial, 10 factorial, plus 10 factorial, 1 factorial, 9 factorial, plus 10 factorial over 2 factorial, 8 factorial, plus, and you can guess what comes next, 10 factorial over 3 factorial, 7 factorial, right? I think we have to add one more. At most 4 ones. So this is for 0, this is for 1, this is for 2, and this is for 3. But we can't forget the 4 because it's at most 4. Right? 4 factorial, 7 factorial. And so what are we going to get for this term here? Well, 10 factorial over 10 factorial is 1. And 0 factorial is 1. So 1 divided by 1, just 1. 10 factorial over 9 factorial is, 10, right? If you can't see that, oh boy. Well, let's hope you can. 10 factorial over 8 factorial is 10 times 9. And then we have to divide it by 2 factorial, which is just 2 times 1. Plus 10 factorial over 7 factorial is 10 times 9 times 8, all over 3 times 2, plus this is, 10 times 9, I'm running out of room, over 4 factorial, right? And so this is going to be 11 plus this thing here. This is all going to go to, what's 90 over 2, 45, plus 10 times 9 times 8, I'm going to do this on my calculator. 10 times 9 times 8 is 720, divided by 6 is 120, right? Double check that. Divided by 6, yes, 120, right? So this thing here goes to 120, and then this thing over here, right, is this thing. And that's going to be, I'm going to do it on my calculator, 10 times 9 times 8 times 7, whoa, I did a 7 factorial, excuse me. This should be a 6. Sorry. Divided by 4 times 3 times 2. Let's see. What's 5,040 divided by 24? 210. Okay, so we're going to add all these up. Plus 120 plus 48 plus 11. 389. I do not believe that that is the right answer at all. Oh. Let's see. This is page 413 in the book. Let's go to the answer key in the back. S42. Was it 389? Did I do some bad calculations? Oh, it's 386. Oh, no. What did I do? Oh, no. Oh, this is a 45, and I put it down as 48 in my calculator. So the problem was that I inputted something into my calculator incorrectly. This is 45. Still not a very good 5. So this is actually 3... We'll just cross all this up. 386. That is your correct answer. Yes, so every calculation was correct. Okay, let's go on to... yeah, there's a lot of room for error in these. Was it 413? Page 413. Let's go on to part C. At least 4 ones. So this is going to be C... I should really do these this way. C of 10, 4 plus C of 10, 5 plus C of 10, 6 plus c of all the way up to, you know, c of 1010. We're running out of room. Dot dot dot. So yeah, all those, there's a few things. There's 10-8, c of 10-8, and c of 10-9 in between there. And so this is just a lot of calculating. But yeah, basically, c of 10-4. If you guys don't want to do all these, or if you want to just do all these right now, you don't have to continue the video. But we'll just continue. 10 factorial over. This is an awful problem. Anyway, so this is going to give you the correct answer. I'm not gonna go through all these calculations. This is S. Let me just double check the answer. This is going to come out to, what is it? What problem is this again? 848. All these summed up are going to be 848. So yeah, that is part C, and then part D. Where we go? 14. An equal number of zeros and ones. How many bit strings of length 10 contain an equal number of zeros and ones? Well, in order to get that, we need to show what a bit string of length 10 with an equal number of zeros and ones looks like, right? So let's just start from, you guys probably already know this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So yeah, so there's going to be an equal number of zeros and ones, and so there's going to be 5 zeros, 5 ones, right? And so what's the probability, or yeah, what's the number of these there are? Well, there's more than just one. 3, 4, 5. 1, 2, 3, 4, 5. Right? I could have 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Right? It still has 5. Remember, order doesn't matter. Right? So there's a lot. If I was permutating this, right, this would be no, I don't want to say that. That's not true. But anyway, this is just going to be C of 10, 5. 5, we're just looking at ones. 5 ones. What's the probability of getting 5 ones in this? And the answer is 10 factorial over 5 factorial, 5 factorial, times 5 factorial, right there, right? Which is equal to 10 times 9 times 8 times 7 times 6, all over 5 times 4 times 3 times 2 times 1, which is just 6 times 7, 63 times 4. Oh, this is going to be This will be one of those times where I mess up a simple calculation. 252. And that's it.